Hi, I'm Dion from leavingcertmathsvideos.com. Now, just before we start question 5, it's important to know your rule of indices. So I just basically do the two main rules of indices. That is that am to the power of n is equal to a times mn, and then am multiplied by a to the power of n is equal to a to the power of m plus n. We'll leave these rules now for when we continue. So just get that out of the way. Now, what we want to do here, we want to write out the expansion. Now, we want x to the power of 8, that's the coefficient we're looking for. So we have x squared to the power of n is equal to x to the power of 8. So that implies that x to the power of 2n equal to x to the power of 8. So that implies that n is equal to 4. So that's the term we're looking for here. We're looking for 4. We're looking for when we're going to the power of 4. So we write out the general equation here. We're looking for n to the power of 4. Now, we just write out the first two terms just so we won't make any mistakes. So the coefficient is going to be 10c0 times x squared all to the power of 10 times negative 1 all to the power of 0 plus 10c1 times x squared all to the power of 9 times negative 1 to the power of 1. That might go the same way on until we reach x squared to the power of 0. Now, as you can see here, it's just important to notice it always comes in handy. These two powers here are always going to add up to 10. Well, when we have 10 here, that's always going to equal that. 10 there, these two here are always going to add up to 10. And these two terms here are always going to add up to 10 as well. So just remember that because it's going to come in handy right now, among other times. So we're looking for x squared to the power of 4. So that way when we go 10c, we'll just leave this blank for a minute. So we go x squared all to the power of 4 times, this also was that up to 6, power of 6. Now these two here are up to 10, so this is obviously going to be 6 as well. So we have 10c6 times 1, which is 10c6, which is 210. So that's equal to 210 x to the power of 8, and that's the coefficient of x you were looking for, 210. Okay, so moving on to the next question here. We're moving on to a logs question. Now it's just important to know here, like your basic rules of logs. I'll just do a quick example here. If you have log a to the base 2 is equal to 3. What that really means, when you see log a to the base 2, that basically, on the left hand side, that's asking you exactly, that's basically saying to you, what number does 2, what power does 2 have supposed to get to 8? So the answer, basically what this is asking you is, 2 to some power gives us 8. So that's what log 8 to the base 2 means. So the answer is obviously 3, because 2 cubed is 8. So that's just going to come in handy now. Also, you know that if we're using the same basis, the log a minus b is equal to log a over b. So, So we go log to the base 2 of x all over x minus 1 is equal to, now, remember what we were saying about the a example over here. If we look at this here, log 4 to the base 2. So 4 to what power will give us 2? Now that's a bit tricky, but it's actually, like, square root of 4 is obviously 2, so it's 4 to the power of half. So that this whole answer here is equal to a half. So that's equal to 2 on the right hand side, because half of 4 is 2. Now, we also want to get this in the same, like we've log base 2 on the left hand side, we want to get log to the base 2 on the right hand side. So we write 2 and something, log to the base 2. Log to the base 2 of 4, because 2 squared is equal to 4. So that's straightforward. So that means that x all over x minus 1 is equal to 4. And that implies x is equal to 4x minus 4. Implies that 4x, sorry, I'm distracted outside here. That implies that 3x is equal to 4, implying that x is equal to 4 over 3. And that's the solution for that question. Now, on to the next question here. We have, it could be done in logs, like the whole lot, but it's actually, if you know your law of indices, like I was saying earlier, that's why I done it at the very start, you can spot that 3 to the power of 2x, we can just change this, that is equal to 3 to the power of 1 times 3 to the power of x, all to be squared. Because remember what I showed you earlier on, I'm not going to go through it again, and that's minus 17 times 3 to the power of x, minus 6 is equal to 0. Now, we have a common term here. We have a term squared. What we really have here is a quadratic equation. So, just for simplicity's sake, we're going to let y equal 3 to the power of x. 3 to the power of x. So, our new equation is 3y squared minus 17y minus 6 is equal to 0. And we take out the 3y here, and we take out our y here. Equal to 0. Now we have a look at this. The factors of 6 could be 6 and 1. 6 here and a 1 here, and we're going to have a negative number and positive there. So there we have two solutions. Implies y is equal to negative a third, or y is equal to 6. So we're going to go with one of these. Y is equal to negative third time. Is it y is equal to 3 to the power of x? So 3 to the power of x is equal to, well, it's not going to be third. So we're going to do 3 to the power of x is equal to 6. And what we'd have to do here is we'd have to log both sides. Right, so we have log of 3 to the power of x is equal to log of 6. And that is equal, like, log 3 all to the power of x. That's the same, you can bring that x down to another root of logs. So you can read that's the same as writing it that way. So then x is equal to log 6 over log 3. .63.